So here we go, finishing up lesson 8, proving segments and angles congruent. So we have a few theorems here. New theorems we're going to learn. I hope that you have made your flashcards for these because of course you need to memorize them. So the right angle congruence theorem simply says all right angles are congruent. Congruent supplements theorem says if two angles are supplementary to the same angle or to congruent angles, then they are congruent. So if you look at our little diagram here, if the measure of angle 1 plus the measure of angle 2 is 180, so these two here, so those two are supplementary. And if the measure of angle 2 plus the measure of angle 3 is 180, so in other words, those two are supplementary, then what do I know according to this theorem? I know that, let's see, it says they are congruent. So what I know then is that angle 1 is congruent to angle 3, right? Since they're both supplementary to angle 2, then they have to be congruent. All right, how about the congruent complements theorem? Well, it's going to be extremely similar to the congruent supplements theorem, only we're talking about complementary angles. So again, if two angles are complementary to the same angle or to congruent angles, then those two angles will be congruent. So if angles 4 and 5 are complementary, in other words, the sum of their measures is 90 degrees, and if angles 5 and 6 are complementary, then I know that angle 4 is congruent to angle 6. 4 is congruent to angle 6. Linear pair postulate. You will use this so many times in proof you can't even imagine. I think we've talked about this plenty already, but here it is, our postulate. It's not a theorem, but a postulate. If two angles form a linear pair, then they are supplementary. Anytime you have a linear pair, those two angles that make it up are supplementary. So the sum of their measures is 180 degrees. How do I know that? Because that's the definition of supplementary angles. Vertical angles theorem. We all know this. Vertical angles are congruent. So angle 1 is congruent to angle 3, and angle 2 would be congruent to angle 4. And what if I asked you about angles 1 and 2? What would be their relationship? Well, they would be supplementary. How come? Because of the linear pair postulate. Same thing with angles 2 and 3. 2 and 3 would be supplementary. Why? Because of the linear pairs postulate. Linear pair postulate. All right. If two angles, this is another theorem here, if two angles are congruent and supplementary, then each is a right angle. Congruent and supplementary, then each is a right angle. I guess they don't necessarily have to be a linear pair. I could have this angle being a right angle. I could have this angle being a right angle. They're congruent, they're supplementary, but I know that given that, they both have to be right angles. You cannot have angles that are congruent and supplementary unless they're both right angles. Okay, well, a couple more proofs and then we should be done for the day. Let's see what we have here. Angle 1 and 2 are complements. All right, angle 1 and 2 complementary, 3 and 4 are complementary, 2 is congruent to 4, so I'm going to mark that. Prove that angle 1 is congruent to angle 3. Okay, this is the congruent complements theorem, so I cannot use that theorem in my proof. Hopefully I have enough room here. I'll try to write small. Statements, reasons. I think I'll just go ahead and put all my given statements right off the bat. So angle 1 is complementary to angle 2. Angle 3 complementary to angle 4, and angle 2 is congruent to angle 4. So all that's given to me. All right, so what am I trying to prove now? I'm trying to prove that angle 1, I'm trying to prove the theorem, that's right, that says the congruent complements theorem. Okay, so let's see. Let's see what I got to do. I think I'm going to have to, how would I prove, if I prove that they're complementary? Okay, so I'm going to have to prove something about complementary angles. What is the definition of complementary angles? We got to know that. Complementary angles, two angles whose sum is 90 degrees. So I think I got to change over to equality. So I'm going to say that the measure of angle 2 equals the measure of angle 4. And like I told you guys, sometimes you'll start and you'll write some reasons, and in a minute you'll realize that's not really getting me anywhere. That's why we got erasers, so we can start all over and get where we need to go. But I think this is what we're going to need to do. And of course that's the definition of congruent angles, or angle congruence. You could say it either way. All right, so now I'm trying to do something with complementary angles. So I'm just going to start with this given statement right here. And I'm going to say the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And then I'm going to do it again for this statement. And I'm going to say the measure of angle 3 plus the measure of angle 4 equals 90 degrees. And I can do that in the same step because I'm using the same reason. What is the reason for that? The definition of complementary angles. That's how I know the sum of their measures is 90 degrees, because that's the definition of complementary angles. Okay, let's see how that helps me. And once again, I can see that I'm going to run out of room here, so I'm going to have to come over to the side to finish my proof. I'm sorry about that. Okay, so let's look at step number 3. What do we have? The measure of angle 1 plus the measure of angle 2 is 90. Oh, look at step number 2 here. Look at step number 2. I know that the measure of angle 2 equals the measure of angle 4, so I think what I'll do is I'll just substitute that right in there. That's what I think looks like a good idea. Let's see if it turns out to be. So I'm going to rewrite this statement right here. So I'm going to say the measure of angle 1 plus, now substituting in the measure of angle 4, equals 90 degrees. Substitution property of equality. And you may be thinking right now, well, how come you couldn't have just substituted in the measure of angle 4 here without changing to equality between this step and this step? Because there is no substitution property of congruence. There's only a substitution property of equality. So if I'm going to substitute, I have to have an equality statement. All right, now, if you look at these two steps together, look at these two together, you have two quantities here, the measure of angle 3 plus the measure of angle 4, and the measure of angle 1 plus the measure of angle 4, that both equal 90 degrees. So what I can do then is I can say that the two left sides equal each other by the transitive property. So let's see, I think I'll come up here and do that. I'll come up here and do that. So number 5, I'm going to say measure of angle 3 plus the measure of angle 4 equals the measure of angle 1 plus the measure of angle 4. And number 5's reason, this is really terrible that I can't keep my two columns, and I do apologize. The reason for number 5 is I just used the transitive property of equality. All right, so if I look at number 5, if I look at this statement right here, what if I were to subtract the measure of angle 4 from both sides? Hey, I think I'm really getting somewhere now. So number 6, the statement number 6 that I would make is that the measure of angle 3 equals the measure of angle 4. And how do I know that? Because I subtracted the measure of angle, the measure of angle 1. Since I'm not in my columns, this is really messing me up. You might want to write this whole proof on a separate sheet of paper. See, I'm subtracting the measure of angle 4 from both sides, so the measure of angle 3 equals the measure of angle 1. I apologize. Subtraction property of equality. And then finally, you see, I'm almost there. This is what I'm trying to prove. I almost have it, but what I actually have is equality, so I just have to change it now. I have to change it to congruence. So angle 3 is congruent to angle 1. Definition, angle, congruence. And finally, that's not exactly what it says I have to prove, so I have to switch these two around again, and I have to say angle 1 is congruent to angle 3, and that is because of the symmetric property of congruence. All right, 8 steps. Hopefully, I really hope you will rewrite this and put all the statements in a column and all the reasons in a column, because what I have just done here is not good, not easy to follow, and I certainly do apologize. If you need me to help you with it in class or rewrite it out, I will do that. Okay, so that's it for the proofs today. Let's just quickly finish out these little problems that we have here in the diagram. Measure of, angle 3 is a right angle. Angle 3 is a right angle. Measure of angle 5 is 57 degrees. Find the measures of all the other angles. Okay, well we can find, well, the measure of angle 1, that's easy enough, right? Because it's a vertical angle. No, I take that back. Not going to do the measure of angle 1 first. I'm going to do the measure of angle 4, because what do I know about the measure of angle 4? I know this whole thing right here is 180 degrees. So I know that it's going to be 180 minus 90 plus 57. That's going to be the measure of angle 4. So I think that's going to be 33 degrees. All right. The measure of angle 2, oh, that's an easy one. Measure of angle 2, it's a vertical angle with angle 5, so the measure of angle 2 is also going to be 57 degrees. And let's see, how about the measure of angle 1? Well, angles 1 and 2 are a linear pair, right? 1 and 2 are a linear pair, so I know that the measure of angle 1 is going to be 180 minus 57, which is going to give me 123 degrees. 1, 2, and which one am I missing? I'm missing angle, angle 3 is given. Angle 3 is given to me. It says find the measure of it, so I'll write it down, but they told us it's a right angle. Measure of angle 3, 90 degrees. All right, that's how we can use our theorems, not just for proofs, but for solving problems too. Find the measure of angle 1 and the measure of angle 2. Well, what I have here are just some linear pairs. So, and let's see, I have the same thing in this problem. So I would consider these to be fairly straightforward. So I'm going to ask you to pause and do these. I'll write the solutions up, and then you can come back and check your answers. Okay, here are your answers for 2 and 3. Like I said, I just have some linear pair here, linear pair, so I use the theorem that linear pair postulate, I apologize, that tells us that the two angles that form a linear pair are supplementary, and I got those measures there. Down here, again, I got a linear pair, but what I have to do is write down the sum. The sum of these two angles is 180 degrees, and when I solve for x, I get 21, but oops, I almost did not answer the question. Be careful and read the directions. What's the measure of each angle? Well, I got to plug this x in. So let's see over here, I got 63 minus 17. So I believe that's 46 degrees. And then this should be 180 minus 46, which will be 134 degrees. Let me make sure if I plug 21 in there. 6 times 21 is 126 plus 8. Yep, that does equal 134. So there you have it. So you do need to write yourself a good summary for this lesson. We learned a whole lot of things. And if you didn't write an essential question, please go back and do that too. And we'll see you next time.